Hello everybody, this is Mr. Shaban. In today's lesson we're going to have some questions based on the endothermic and exothermic reaction. Before we start with the questions, I would like first to recap with you the meaning of endothermic and exothermic reaction. Endothermic reaction is a reaction in which the energy will be taken in from the surrounding, while exothermic reaction is the reaction where the energy will be given out to the surrounding. We're starting with the workbook questions, page 45. Please get your workbook. We're going to do exercise 4.4. The exercise name is Trends in Groups in the Periodic Table. The first question over here is asking you to explain what is meant by a group. So a group in the periodic table is a column of elements. So the column of elements, we call it group. Right now I want everybody to look at question 2. I'm going to give you 3 minutes in order to figure out the answers for these questions, and after the 2 minutes we're going to double check the answers together. Okay guys, time is over. Let's double check the answer. The table contains some data about the elements in group 7 of the periodic table. The elements are given in the descending order. So you have fluorine, you have chlorine, you have bromine, you have iodine, you have astatine. The atomic number is following from 9 up to 85. Melting point, as you can see, it's minus 220, minus 101, and minus 7. Boiling point minus 188. minus 34 and 59. As we go down, as you can see, melting point increases. As we go down, boiling point increases. This is an increase because, as you can see, it's negative, so it goes up to 0, and then from 0 is going to increase in a positive value, exactly like the boiling. It goes from negative up to positive. Reactivity, fluorine is the most reactive. As you go down, the reactivity decreases. So the first question, what trend can you see in the group of the periodic table? As you can see over here, for the melting point and the boiling point. So melting point increases as you go down the group, boiling point increases as you go down the group, and the element become less reactive as you go down the group. You feel free to write any of them or all of them. All of them are going to be considered correct. Second question, iodine is the fourth element in the group. Would you expect the melting point of the iodine to be higher or lower than the bromine? I want you to compare iodine and bromine. So double check. We said as we go down, the melting point and boiling point both increases, right? So the answer for this question, the melting point of iodine will be higher than that of bromine. The third question, would you expect iodine to be a solid, liquid, or a gas at a room temperature? And please give us an explanation for your answer. The answer for this question is going to be solid, because the melting point is above the room temperature. You know, room temperature is 25 degrees, and as the melting point is going to be above the room temperature, so we're going to have it as a solid. Perfect. Would you expect iodine to have a higher or lower boiling point than astatine, and give your reason? The answer for this question is going to have a lower boiling point, because as we go down the group, the boiling point increases. So that was the answer. Iodine is going to have a lower boiling point than astatine. Would you expect astatine to be more or less reactive than iodine? Of course, it's going to be less reactive, because the most reactive found at top. As you go down, the reactivity decreases. Okay guys, for the exercise 5.2, I'm going to give you 3 minutes in order to figure out the answers for these questions. The last question is more about practical based question style, so please think about it carefully, try to figure out the answers, and I'm going to revise with you the answers after 3 minutes. Okay guys, time is over. The first question, write a word equation for burning sulfur in oxygen. We're going to have sulfur plus oxygen is going to give us sulfur dioxide. As you know, before the arrow we're going to have the reactant, and after the arrow we're going to have the product. Write a word equation for the reaction between magnesium and sulfuric acid. We're going to have magnesium plus sulfuric acid as going to produce magnesium sulfate along with hydrogen. Again, before the arrow we're going to have the reactant, and after the arrow is going to have the product, and rearrangement has taken place. Magnesium has taken the sulfate group while hydrogen was given off as a gas. Third question, when magnesium ribbon is placed in the sulfuric acid, as a chemical reaction takes place and heat energy is given off. Right now there is an investigation where the people need to study the effect of changing the length of magnesium ribbon on the increase of temperature. Will the reaction produce high temperature with using a smaller length, a smaller piece of magnesium, larger or medium piece of magnesium? That's what they want to know. Explain what preliminary work they could do and how this would help them plan their own investigation. So first of all, the work that they need to do is to find out what change in length of magnesium ribbon is needed to produce an change in the temperature. So they need to ensure that they are measuring the increase in temperature before losing too much of the heat to the environment. They need to control this factor. They need to make sure that they can measure the heat produced instead or before losing the heat to the environment. This could help them plan their investigation so that they don't waste time on changes in the length of ribbon that don't produce a measurable increase in the temperature. I hope you have understood this exercise. This exercise is very important. Right now we're going to continue with the course book questions. Please get your course book on page 74 and 77. I want you to take 3 minutes in order to figure out the answers for these pages, and then we're going to figure out the answers together. Okay guys, time is over, so let's discuss the questions one by one. What are the reactant in the reaction shown in the word equation above? The word equation, you can find that sodium hydrogen carbonate and citric acid both are found before the arrow and both are considered to be the reactant. Second question, which are the products in the reaction shown in the word equation above? So the products always are found after the arrow. So the products are sodium citrate, carbon dioxide along with water. Third question, what is an endothermic reaction? As we have taken earlier, endothermic reaction is a reaction that takes in heat from the environment. Fourth question, explain why eating sherbet sweets makes you feel your mouth feel cooler, because it's a certain kind of endothermic reaction where the sodium hydrogen carbonate and citric acid react together, and they're going to take the energy from your mouth, as it's the environment which is found inside the sherbet, which is found surrounding the sherbet sweets. So you're going to feel cooler because this reaction has taken the heat energy from your mouth. That's why you feel cooler. Fifth question, you may also get a fizzy feeling in your mouth when you eat sherbet. Why is this? The answer, because the fizzy feeling is due to the carbon dioxide which is given off, so you're going to have this fizziness inside your mouth. Next question, why is ice melting called an endothermic process and not an endothermic reaction? Because melting ice does not produce new product, no chemical change has taken place, so it's a process. Seventh question, suggest a change of state other than ice melting that is an endothermic process. Any change in state apart from melting, we can have evaporation, this changing the liquid up to gas. These also can be considered endothermic reaction because you need to heat the liquid in order to get the gas. The next question, when you have been swimming and you come out of the pool, you may feel cold. Use your understanding of endothermic processes to explain why. As you know, we feel cool because the particles of the water which is found on top of our skin will gain energy and evaporate. So they take the energy from our skin in order to change from liquid to gas to escape to the air. That's why by losing the heat energy from your body, you're going to feel colder. Next question, suggest whether water freezing is an endothermic or exothermic process, and can you explain your suggestion? We said freezing is a process where we change liquid up to gas. So when you change liquid up to ice, solid. So when you change a liquid to solid, actually the liquid tend to lose the heat energy in order to change into solid. So losing the heat energy is an exothermic process. It's an exothermic process because the water tend to lose the heat energy to the surrounding in order to change into ice. I hope you have enjoyed today's lesson and see you next time.